So for this problem, it's asking us for number 6, a solution of sulfuric acid has a molarity of 0.49 m. What is the H plus concentration? So we're trying to find what the H plus concentration is, but your first step is to always look at your compound and figure out if it's an acid or a base. So we look at H2SO4, and we know that this is an acid because it begins with the letter H, so it begins with hydrogen. So we know since it begins with H, we can right away find the H plus concentration. So your first step, since we're using this as a formula, is to figure out what each of the variables is. H plus we know is our X. M we know is 0.49. The number of H's we need to figure out by dissociating our acid. So we're going to take H2SO4, dissociate it into H plus and SO4 minus 2, and balance it. We only care about the number of H plus ions. So since we look here, there's our H plus ions. We don't count those H's because they're not in ion form. And we look and we added a coefficient of 2, so we know H plus equals 2. So now we plug everything into our equation. So we have H plus equals 0.49 times 2. And we calculate that out. We would get our H plus ion to total 0.98 m. And that's our final answer, since it's just asking for our H plus concentration. Okay, the second problem, so number 7, it says we have a solution of 2.3 grams of phosphoric acid and 200 milliliters of water. It's asking for our H3O+. If you remember, H3O+ is the same thing as H+. They are synonyms for each other. So we're still just finding our H+ concentration, so we can use this formula. Well, we want to make sure our compound's an acid, which it is. It's phosphoric acid, which would give us the formula H3PO4. So we know we have to go through and find those 3 variables up there. So we know H plus is our X, that's what we're trying to find, which again is the same thing as H3O. We know M, we need to find, and we need to find number of H's. Number of H's will be the easiest to find by dissociating it, so we have H3PO4, dissociate into 3H plus PO4 minus. That gives us a total of 3 H's. Now we need to find M. If you remember, M is moles over liters. So we need to convert our grams into moles, our milliliters into liters. So we know 20,000 milliliters is the same thing as 20 liters. 2.3 grams of phosphoric acid we convert to moles using our picket fence. And so since we know our molar mass is 36.46 grams of so we're going to take that back. The molar mass is 98.079 grams per mole. That'll give us a total of 0.023 moles, which we can then plug into our molarity equation, which would give us 0.0018 m. So now we go through, we plug it in our equation, so we have H plus equals 0.0018 m times 3, and that would give us 0.0035 m. And that would be our final answer. Okay, the next problem is exactly the same as the first, except for now we're finding our hydroxide ion. So this one only works if we're talking about something that's a base. So we have a solution of sodium hydroxide, which is NaOH. Okay, we know this is a base. It ends in OH, so we can use this formula without doing any conversions. So now we know our OH is our X, because that's what it's asking for. Then we know our M is 0.29, because it gives it to us. Our number of OHs. So again, we dissociate it to figure out how many OHs would be produced. We balance it, and that would just give us 1. So we just plug in OH equals 0.29 times 1, which would give us 0.29 m. For homework, and you need to do this in the homework section, you need to do problem 9.